Hello everybody, this is Toby Delbrick again. In this tutorial I'm going to show you how to use the AEViewer from jAER, jAER, and explain some of the file and view and other options. I'm going to launch jAER Viewer using this launcher for AEViewer. If you don't have that locked on your taskbar, what you can do is go to the jAER folder where you've either downloaded a runtime release or compiled jAER. Of course, you can run it from the development environment like NetBeans just by pushing Run button, or you can go to the jAER folder and run this executable here, which will launch the virtual machine and start jAER. In this case, I've dragged it onto my taskbar in Windows, so I can launch it from there. So now that will start the AEViewer. In this example here, I'm going to use a recent prototype camera, Davis 346, and I'll use that to explain how to do some of the things from the file menu. So the file menu is where you open log data files, where you start logging and stop logging, set logging time limits, and various other options, including remote options for streaming data using unicast or multicast or TCP connections between viewers. Two very important menus, or very useful menus in the file menu here, are the list of recent files that you've worked with and the recent folders that you've worked with. These are great for going back and looking at previous recordings. So in this example here, I'll take some pendulum data that we recorded in Telluride just to explain some of the view options. Now you see right now this pendulum, which is swinging back and forth here, is rendered as red and green dots here. Black where there's no events, and red and green where there are events. Now what I've done is right click on the viewer somewhere, and every time a pixel makes a spike, you hear a spike. You should actually hear stereo sound. Maybe you don't hear it because you're just hearing the microphone here, but try it yourself and you'll hear spike sounds as the pixels spike from this dynamic vision sensor. I'm going to use the C key, and if you notice down here it says every time I push C for color mode, it changes to a different color rendering mode, hot code, gray level, and I'll use gray level for now. Now I'm going to use the mouse wheel to scroll up and down the contrast. If I do that, not sure what went wrong there, but if I start playing this recording again, as I scroll the mouse wheel up and down, you'll see this FS scale. That's the full scale value in events. So right now a single event draws the pixel full white or full black. If I roll the mouse wheel down or push the down arrow button, as I'm doing now, or go into the view menu and look here for down arrow, should be somewhere here, down, down, decrease contrast, or up, increase contrast. That changes the rendering contrast. I'll explain first here what's happening with this information bar here. So this first number here shows the amount of time that's being shown on the display at the moment. This shows the absolute time in the recording, 158 seconds. This shows the number of events that came in on that particular packet and the number that came out after some filtering operations, which you've applied. This shows the event rate, which at the moment is 5 million events per second, so 5,000 kilo events per second. It's paused. If I put the space bar to play again, it'll play. This number over here shows the real-time rate. So this is playing at 500 millis real-time, so about a half real-time. This shows the achieved and desired rendering rate in frames per second. So the desired rendering rate has been set to 32 frames per second. It actually achieved 28 frames per second. And this shows the amount of free time at the end of each frame that the CPU had to wait. And this shows the number of skipped frames, and this shows the full scale value. View menu is one of the menus in jAER that had a lot of attention because we had spent a lot of time looking at data in different ways. Second menu is the AE chip menu. That's where you choose the particular device or camera or cochlea which you're looking at. So basically it defines a software object that defines everything about how the data is rendered, how the device is controlled, and so on. The next one is interface menu. If you have a device plugged in, it'll show up here if all goes well. Otherwise, for particular devices like the embedded DVS or Spinnaker hardware interface, you can go and choose a particular interface here, either TCP port or COM port, and so on. Then there's a USB memory menu, which I'll come to later because I'm not dealing with hardware here at all. There's a Davis menu that allows you to, when you're using a Davis chip, like this Davis 346, that allows you to control how data is rendered and also what data is collected from the device. So for example, if I do Shift F here, it'll start showing the frames collected from the device. Shift F, frames off. Shift F, frames on. Shift E for events. If I turn the frames off, now I can turn the events off, so there's nothing showing. On, events shown. Other menus here allow you to control the active pixel sensor auto contrast. So if I turn off the events and turn on the frames and hit the Shift C here, every time you toggle it here, it'll control the contrast of the displayed data. The histogram display shows the histogram of pixel values, and auto exposure is for automatic control of exposure duration, and this other stuff is also for Davis. Another useful menu is this help menu that opens the user guide, the help forum, the project home on GitHub, a hardware user's guide on innovation, and a flashy reflashing utility help to help you reflash firmware when needed. By the way, use this with caution, because firmware operations are always touchy. The About menu shows you the actual compiled version. In this case, I'm actually running something that was just built today, and it's running from the development branch, which is currently called AEViewer-Bag Reader. Now let's go back to this View menu here. This allows you to do lots and lots of stuff. For example, open the biases window. Another way to get to this window is to open this hardware configuration button. We'll come to that later when we come to hardware control of cameras. Another thing it allows you to do is show the filters window. This is also extremely important. This Control F to show the filters window, or this filters button pops up your loaded event processors. That's also the subject of another video. So let's just focus here again on view items. So you can increase and decrease contrast. You can set auto contrast for some chips. It'll automatically set this full scale value. You can accumulate the image. So let's show, if we turn the frames off, and let's cycle the color rendering mode to red and green, and rewind this data again and play it. I'm not sure why the events are, okay, so now I've showed the events again. Now if I hit P for accumulate image, it will just leave the data there and not reset the rendered frame all the time. So that's useful to see the hot pixels, level of background activity, and also where stuff is changing on the sensor. So we'll turn that off again. You can ignore the cell type. So right now we're showing on and off separately, but if I ignore cell type, it renders everything as on only. So let's turn that off again. Now, two very important menu items are increase the rendering frame rate and decrease the rendering frame rate. So I'll make this full screen here so we see it a bit better. If I hit the right arrow button, watch this number over here. Now it's gone to 64 frames per second, or 128 frames per second. If I decrease it especially, I can slow down the rate at which data is rendered to the screen. So if you find rendering rate has suddenly dropped very low, it may be because you've gone to a very low rendering frame rate. That's actually good for debugging some kind of processing filters. Let's set it to a normal frame rate here. You notice that it maxes out at about 30 frames per second. That's probably because there's a graphics option set here. Actually, I'm not sure why it's maxing out at like 30 frames per second. There's no good reason for that right now. Because in the software, it'll go up to like 500 frames per second. The purpose of going to such a high rendering frame rate is that if you're closing a real-time control loop, then you want to deal with the data as quickly as possible to reduce the latency. So here's another important command, of course, is to pause and to resume. That's just a space bar. Dot is something, if you hit dot or period, then it'll go frame by frame. You can hit space again to go real time. Another useful thing is to increase and decrease the playback speed. Basically, increasing the playback speed makes the time slices longer, decreasing makes the time slices shorter. So let's loop over a piece of data here. I'll actually just hit F And now you see that this number on the top left is increased, so it shows more time per rendered frame. Or I can decrease it to say 600 microseconds per frame. F, increase. S, slower, decrease. So that's very useful when you want to look at data. Another thing you can do is toggle the playback direction, or rewind the playback. So let's rewind back to the beginning, rewind back to the beginning, rewind back to the beginning. Or we can hit B, stands for backward. That means that we're toggling the playback direction. You'll see every time I do that, that it changes the time being rendered here from a negative to a positive number and vice versa. So let's go back to normal forward playback, rewind the recording. And let's see, now another useful thing is flex time playback. It enables playback with a constant number of events. So right now we're rendering 10 milliseconds per frame. If I hit T, we're now changed to rendering 128 events per frame. I can hit F again to render more events, 65,000, or S to render less events. In fact, you can even slow down so much they're rendering single events from the sensor. That's usually not very useful. Okay, so let's make that longer again and go back out of flex time mode and reduce it back to a reasonable frame rate. And the next menu item is to forward or reverse a certain number of packets. You can use Control-Shift left to rewind over a recent piece of data. You can set the number of rendering frames that actually happens when you do that. Now, two more useful items are setting an in and out marker. So if I set an in marker here and an out marker here, now it just goes over this piece of data, and that's indicated by this control at the bottom of the screen here, which shows you the data you're actually playing. I can drag it to wherever I want in the recording, and then when it gets to that piece of data, it will just cycle over it over and over again. That's very useful for debugging certain algorithms. If I want to erase those markers, I use M to erase markers, and every time you do that. So left bracket to set the in marker, right bracket to set the out marker. Set a new out marker, so you can zoom in, even a new one. Now you get an exception, uncaught exception. So if you get an exception like this in jAER, and you want us to figure out what's going on, then you can copy this trace here, what you get in the uncaught exception window. You see here there's a Stack Overflow error. And then you can open the user forum and post that to the user forum. And that way it's likely that somebody will go and fix the bug. If you get such an uncaught exception, it doesn't mean the end of the world, even if you're doing a recording, because it's likely that it's just an exception that's somehow not caught but somehow still dealt with. So if you're lucky, you can just simply open a new recording or rewind the recording, and sometimes that will fix the problem. If not, just quit and restart. But please report those uncaught exceptions because we're very eager to fix them. So I'll restart jAER again, and let's look at a few more items having to do with viewing data. So I'll play a new piece of data here, for example, from a bag file. So the native file format of jAER is .aedat. That's a binary data file containing just event addresses and timestamps. It has a text header that includes the time it was recorded, the device ID, all the settings of all the filters and so on. But basically it's just a simple binary file. There's another file format called BAG, which comes from Robot Operating System, or ROS. jAER now in the latest release or latest development branch supports reading BAG files. So if I go look at this downloads folder, you'll see this HDR boxes is there. Normally when you go to any other folder that has an AEDAT file, as soon as you go on the file, you can get a video preview of it. It doesn't work actually for BAG files yet. But if I go and open that BAG file, you'll see that it now will play that BAG file. Now this is coming from a different chip. It's a Davis 240C. So you see when you render in a Davis 346, it's smaller. If you want to now look at this other recording, just switch to the Davis 240C chip object, and it should render it properly. Not sure why that didn't work. There was probably some bug in constructing this chip object. So let's close this file and go back and try to open this Davis 240C. Okay, so now is it a Davis 240C? Yes, it is. And now let's open this bag file again. HDR boxes. Okay, so there it is. So you see this consists of high dynamic range scene with events and frames. And this is part of a data set recorded by the Robotics and Perception Group at the University of Zurich, where they also track the camera motion using an OptiTrack system and recorded frames and events and inertial measurement unit output, which is shown by these data in the middle of the screen. So let's close that file and go back to another one. Here's a set of recordings recorded from Davis 346 or Davis 346 Mini, which is two people showing Rochambeau symbols. You can go back to the normal color rendering mode, and it's a bit out of focus, but that's okay. I want to conclude this by going down here to showing you how to zoom in and out. So if you do page up, page down, you can zoom in and out on the data. Every time you zoom up, you're zooming in centered on the mouse cursor. If you don't want to look at individual pixels anymore, just push the home button and you go back to a full screen mode. You can also unzoom as I just did with home. You can set the border space around the display if you're making a video. And now another very important or useful method or interesting method is to change the display method. This is the basic rendering method for showing the data from one of these dynamic vision sensors or Davis cameras. Normally we show it like an image where we show a certain amount of time squashed into the picture and the events are rendered as a 2D histogram onto the screen. You can also show data as a space-time display method. So now what we've done is to take the data, instead of showing it in space, we show X and Y as the spatial axis and time is now going towards us. If you use your mouse, you can drag around the screen. You see that it's now showing 20 milliseconds per frame. If I hit F here, you can increase the amount of time per frame. If I go back and play this pendulum data, perhaps it's a bit more interesting. So now I'm playing the pendulum data. If I show actually a lot of pendulum data time, like say several hundred milliseconds, and pause the display, now I can rotate it around and I can see that this kind of shows how the pendulum is swinging across the screen. And it also allows you to explore spatial temporal structure, the background noise from the sensor, see hot pixels. In this case, it actually exposes the string, which is supporting the pendulum, and so on. If I now unpause it and decrease the time back to some reasonable value, say 20 milliseconds with S, and go back to the normal color display, which I got to, by the way, I got to the 3D rendering mode by going to View, Display Method, and I selected Spacetime Event Display Method. Another way to cycle the display method is just hit the 3 key. 3, which is kind of a mnemonic for 3D. If I hit this 3 key, I'm going to cycle between different display modes. Let's go back to a reasonable playback time here and someplace in the recording. And it's now set to a very, very short time, so I'll turn it up to a reasonable time. I'll set an in marker and an out marker. Okay, so now it's rendering over that period, that section of the display. And I'll cycle between the different, one more display method I want to show you is this rolling space-time display method. This shows you the data which has been recorded. Hopefully, you now see this as a cube in 3D where this blue rectangle is in front and the red one, hopefully, is in back so that it's far away from you. Red stands for red-shifted or old. Blue is young. So now this shows you color-coded the events within this time here of 60 milliseconds for the data we just looked at. I believe the up and down arrow keys, yeah, set the amount of time here. So if I now use the down arrow key, this is quite cool because it now shows you the swing of the pendulum and my finger pushing it over a 1 second period. If I pause this somewhere, I can now go, and there's a new display options menu that enables additive color or enable large event points. So you can set some options about how you actually show the data here. So I hope this helped to show you some of the things that you can do for looking at data from a sensor. The best way to learn is just look around the menus and play around with options and ask for help on the help forum. Thank you for your attention.